try one more example here. We want to identify all the angles between 0 and 2 pi whose cosine is negative root 3 over 2. So I'll start by drawing my unit circle. That's not quite straight. Let me straighten that up a little bit. Okay, cosine is negative root 3 over 2. Now, the cosine, remember, is the x value. So I'm going to go on the x-axis, and I'm going to go to negative root 3 over 2. There it is. So that's negative root 3 over 2 on the x-axis. And then I'm going to draw and see what angles I get from that. So it looks like, remember, root 3 over 2 is one of my common values. That means that the y values are going to be 1/2. And I need to figure out which angles those are, but that's one of my common values, 1/2 root 3 over 2. That means that's a 30-degree angle. That's 60. That's 60, and that's 30. So I just need to figure out what those angles are. Well, if you remember, you start at 0. There's 90. There's 180, 270, and 360. That first angle there it's 30 degrees short of 180. So the first angle is 150 degrees. The second angle is 30 degrees past 180. So that's 210 degrees. So I've got my angles in degrees. I'll convert them into radians. Times pi over 180 is equal to 5 pi over 6. 210 times pi over 180 is 7 pi over 6 radians. So I've got those two angles in radians now. That's the first one, 5 pi over 6. That's the second one, 7 pi over 6. And identify which quadrant each one's in. One of them's in the second quadrant, one of them's in the third quadrant. Quadrant 2 and quadrant 3. So again, it all comes back to recognizing those common values. 1/2, square root of 3 over 2, square root of 2 over 2. Once you recognize those common values, you can put these triangles in any position, anywhere in the unit circle, and you just figure out where's your root 3 over 2, where's your 1/2, where's your root 2 over 2, and then you figure out which one's positive and which one's negative. The whole point of this is that you can figure out the sine and cosine of any angle anywhere on the unit circle as long as it's a multiple of 30 or 45, or in terms of radians, if it's a multiple of pi over 6, pi over 4, pi over 3, you can figure out sines and cosines of all these angles just by going back to those three common values and by figuring out whether their sines and cosines are positive or negative. So now you know how to find sines and cosines of special angles. This is educator.com. Thanks for watching.